All right, Mr. Hong here with another video, and today we're going to be talking about 510, which is the last section before our 5A summative grade. And today we're going to be talking about solving quadratic equations, or inequalities, sorry. Inequalities, if you remember, inequalities consist of the following. Like y is less than x, y is greater than x, y is less than or equal to x, and y is greater than or equal to x. So these four things are the situations that you can have. And all of these four things talk about different situations, as I said. We know that the less than and greater than signs, these are dotted because they are not equal to. So if I graph this, if you remember, we do like in a graph, we do our graph in a dashed line because we do not include it. But what about the less than or equal to or greater than or equal to sign? What happens here? Or how would we be able to shade or to draw this? Like, for example, if I had like y is less than or equal to 3. I would graph this with a solid line because I do include everything on this. So like this. This is a solid line. So those are two situations grouped together. Now let's talk about the, like, let's say y is, we're gonna use the same example. Y is less than or less than or equal to 3. If I say that they're both less than, or the inequality is facing away from the y, we can, well, first I'm going to draw my graph. I'm going to graph this one. So like this, again, this is y equals 3. I would shade downwards because anything below this would be a solution, as you know, from our past examples, from previous units. So this is below. So what happens if the inequality faces towards my y? What would happen? So I'm gonna shade this one, or I'm gonna draw this one because I drew a solid line. I would have to shade whatever is above. I would shade above my line. So just a quick review of what is expected of you from prior knowledge, from previous learning, and this is going to help us because today we're not talking about linear. We're not talking about just linear anymore. We're talking about quadratics because quadratics is the theme of Unit 5, which is quadratics. So we wanted to start off today by doing kind of like a review. So if we look at this problem for review question 1, it says to graph the inequality of y is greater than or equal to x plus 1. So what is the first thing that you have to understand how to do? We would have to first graph it. And that's really important because what am I going to shade? How am I going to draw my line if I don't even know how my line looks like? So we start with the y-intercept, and then we just follow the slope, which is 1. So we go up 1, to the left 1, or to the right 1, sorry. And then we just draw our line, like so. So we have to ask ourselves, solid versus dashed. So which one is it? It is solid this time because it is an equal to. So the line below the inequality shows you how to draw your line. So the next question you should ask yourself is, where do I shade? And you really have two choices. You have down or up. So let me give you some time to see if you understand that. Which way do I shade? Hopefully you answered that question by yourself and you shaded upwards. And the way to figure that out, because it's kind of confusing, is I like to choose a random point in my graph, kind of like this, and just draw an up arrow, going straight up, like so. Anywhere around like this arrowhead or whatever's touching the arrow that I'm drawing, because these arrows are not part of my graph, but it shows me the area or like the solution that I can have. Because let's say I choose a random point like here. So my question to you is that order pair part of my solution? And the shaded area represents your solution. So this is yes. This is -1, 3 is a solution. As in, it makes sense that this thing would be part of my solution. And the reason why is because it's in the shaded area. So lots of things to remember from previous lessons. So let's talk about what we're going to be learning today, or what you will learn. So how will you be able to solve quadratic inequalities? And this is talking about the shaded part. We can analyze tables. I can give you a table if I want to, which could represent, a quadratic. Or I can give you a graph, which is also a quadratic. Oh, I misspelled that, sure. Or a related function, which is also a quadratic. There you go. I spelled it right that time. But yeah, we know that there's ways to represent a quadratic in many ways. So the review was, you've seen this before, or you remember doing this before. And we've only done it, so far in linear equations. But now we are going to be talking about how to do this with quadratic equations. So the only thing that's new should be, how do I graph quadratics? And we're going to be talking about that in our examples today. So just real quick, let's do this review again. So let me give you some time right now to do this by yourself. Like an Edpuzzle question will be like a spawning of what is your solution. Okay, so if I write this plus 0, I can write this for free, because isn't like 3 plus 0 really the same as 3? I don't need to write this 0, but I can add it if it's convenient for me. Most of the time, it won't be convenient. But for this, it is convenient, because 0 is equal to my y-intercept. So this has to be a point in my graph. So this -2, what does this -2 represent? This is representing my slope. And this slope is -2 over 1. which means I go up -2 and I go to the right one time. But if I'm going up -2, think about I have to go the opposite direction because of this negative. So I need to go 1, 2. That's really bad. 1, 2, and then go 1 like that. So my new point would be here, or another point, not a new point. So if I follow this trend, I would go 1, 2 up, and if I go up twice, that means I have to go opposite direction. Because if I want to make this fraction negative, I can either choose to make the top or the numerator negative, or I can make the denominator negative. It doesn't matter. As long as one of them is negative, it makes sense. So I'm going up to -1 for the x-axis, which is to the left. Nice. So just like the series of questions I asked myself, here, I have to do this. So I've already graphed. So I need to ask myself, is it solid or dashed? And hopefully you concluded to the fact that this is dashed because there's no line below the inequality. And Mr. Hong can't write or draw straight because he's using an XP pen, but you're fine. Like, you understand the general shape of my graph. I also identified 3 key points in my graph. So this shows me that, or I'm showing you that I could graph this perfectly if I had a ruler or if I was doing this on paper, but generally, I know that you understand the shape if you show me 3 points and you show me the general shape. So, next question. Let's see. I asked myself the way that I draw my line, and now I have to ask myself the way that I shade. So, the way that I shade, because my inequality is facing away from my y, so this is red, as y is less than -2x, do I shade up or down? Or left or right? I have to shade downwards because my inequality is facing away. And I've shown you this here. If my inequality is facing away from my y, or for example, this is y is less than 3, I would say, okay, I need to shade below my graph. So the way that we do that is choose a random point and draw a line straight downwards. Like this. Sure, it makes my graph look ugly, but it helps you because I can now say that, okay, anything below this line is part of my solution. So like this, anything inside this area, I'm not going to draw that all the way, is part of my solution. So one thing I would probably ask you is, hey, give me an order pair that pretty much, is part of the solution. I can choose this point. I can choose that point. Sure, I can choose this. I cannot choose this because it's not part of my shaded area. So, -1, -1, sure, which is this order pair right here, is a solution. So I have these questions below right here, which should help you kind of guide yourself into these questions. So solid or dashed line. I used a dashed line for this one. I shaded downwards, and I listed a solution, which is -1, -1. Perfect. So if we can do this with linear, that means that we can, or which is a graph or a type of line, I can do this with a quadratic. And the way that we identify quadratics, if you remember, is with a square on the x. So the biggest hurdle is, how would I be able to graph this? Next question would be, how do I draw my line? And the last part would be shade. And extra credit would be like, give me an order pair. So a couple of quick things. Well, let's say, for example, I don't know what my graph is. But if, for example, if I have this graph like this, x squared minus 1, I can ask myself, what is my h and k, which represent my vertex? So let me put like a question right here, saying like, or asking you, where is my vertex? In 3, 2, 1. Okay, so this is actually a trick question because just like how in my question above, I didn't have a y-intercept for free. Like I didn't print that out for you. Like you had to write that +0 because it was convenient for you. So in this is a standard form technically, but I can also write it as a vertex form, which is, x minus 0 squared minus 1. So my vertex, this would be h, and this would be k. So my hk would be 0, -1. The vertex is key into graphing our equation, or our inequality in this situation, but sure. I know for sure that this is part of my graph because this is the vertex. The vertex is pretty much the middle of the graph. But how do I solve it now? I can plug in x points if I really need to. So x squared minus 1 is less than 1. So let's say I put in 1 for x. So 1 squared minus 1 is less than y. Sure. This becomes 1 minus 1. This is 0. So my y is less than 0. And let's just make this an equal to, just for like the purpose of me trying to graph it. So my y is 0. My x that I plugged in was this 1 right here. So my x is 1, my y is 0. That means that my ordered pair would be 1, 0, which is located here. So I can do this millions and millions and millions of times, but I was going to do it one more time. So let's do here. And I'm going to just put y is equal to this time because I'm just trying to find my points for my graph. Y is equal to x squared minus 1. And I'm going to make this x into, since this is part of my grid, I'm just going to put that as my x. So I have this, y is equal to -1 squared minus 1. And this can be split up as -1 times -1 minus 1. And because of PEMDAS, I have to do this first. And even if I didn't put the parentheses here, I just did that for educational purposes. But I know that this is a multiply right here because I'm squaring this. So -1 times -1 is +1. So +1 minus 1 is equal to 0. So x is equal to -1 because I substituted this x for this -1. My y is 0 because I got my answer to be 0. So my ordered pair has to be here. So I have my vertex. I have this shape coming up. And I know that a quadratic has a U shape. We've already known that. We talked about that in the first section already in this unit. So really, the next point would be like here. That's true. You can do this one more time. But I know already that you can solve it because you already found 3 points. And you know the general line or the general shape. So now that we've graphed this vaguely, I have to ask myself, did I graph this correctly? So I'm going to erase this line just because I know the shape of it. But now you have to ask yourself, is it dashed or is it solid? This inequality right here shows you that it is a solid line. So, once again, the same concept, just different graph. Because we know how to do everything else besides graphing this. Well, we're not comfortable graphing this. Sure. So this is it. Even though I missed this, I know for sure that you know some of them. Or you just missed it because you can't draw. Me too. Okay. So I drew the line. I graphed it. I need to shade now. So do I shade up or down? I would shade up because my inequality is facing towards the y. Nice. And then the last part is to give me like an example of an order pair that would be part of my solution. For example, I can do this right here. I'll do it red. So this right here, this could be 0, 0. This blue point right here can also be part of your solution, only because this is a solid line. So this is 0, -1. So these are great examples. So really just going over how to graph these inequalities or these quadratics will help you solve this problem, because everything else is just review. So we're going to meet back in class to talk about example 2 and example 3. All right. See you there.